This is Gay-Lussac's law.
So we're going to be demonstrating the Gay-Lussac law, which states that temperature and pressure are directly related. So, and that's because as the molecules get excited from the heat, which is energy, and the energy is just going to convert that into kinetic energy, which makes the molecules move around more. That's going to exert more pressure on the outside of the container of whatever the gas is in, which in this case is going to be a balloon. So as we put the balloon and heat it up over this boiling pot of water, it should expand because of the pressure inside of it. So we'll do that. It's getting bigger, and there's a lot more pressure. I can't make a dimple as big anymore. And maybe if we leave it in, I doubt that we have enough pressure or air in there to make it explode, but it definitely did swell. And you can't press it as much. Well, it's kind of dimpled too. Like, that side's a little bit bigger. And now it's kind of contracting in my hand as it gets colder. Oh, yeah, and as soon as I put it over the hot, it just bubbled back up again. I could feel the pressure expanding on my hand. And it's smaller and smaller. Here, get a close-up of this. Just watch for it to, I'll hold it like that, and it's forcing my hand out. And that's Gay-Lussac's law. To make this more interesting, we're going to explodiate one, just because Gay-Lussac's law is awesome.
Oh my. So in Gay-Lussac's law, the original equation is P1 over T1 is equal to P2 over T2. What we're going to do is make the list of known and unknown. And what we know is that P1 starts at the standard temperature, or standard pressure, which is 1 atm. And again, room temperature is approximately 293 Kelvin. The boiling water, 100 degrees Celsius, which is 373 Kelvin. And the pressure, the P2, is what we're trying to find in the unknown. And the volumes, regarding this equation, are the same. They cancel out in the end. So what we're going to do is we're going to take the equation P1 V1 over T1 is equal to P2 V2 over T2. And since the volumes are the same, they're going to go ahead and cancel out. And we're going to go ahead and write the new equation solving for P2. So we're going to go ahead and multiply both sides by T2. So we have P1 T2 over T1 is equal to P2. We're going to go ahead and plug in the variables that we know from the known. P1 is equal to 1 atm, T2 is 373 Kelvin, and that's all divided by T1, which is 293 Kelvin, and that's equal to P2. The kelvins in this are going to cancel out, and 1 atm times 373 is just 373. When you divide that by 293, you end up with 1.27 approximately, and that's in atmospheres. And that is equal to P2, which is the pressure.